morning everybody, and welcome to our lecture 12, our last lecture for Skip 140 Science in Our World. So we're looking at our place in space, part of our Earth Sciences is our last topic to finish off with for this semester for our lectures. So space isn't remote at all, it's only an hour's drive away if your car could go straight upwards. It's an interesting concept for our students. The solar system. So the Earth is one of 8 planets that orbit the Sun, and the Sun is a star, so it's a burning ball of gas that emits light and heat energy. So it's very heavily laden with hydrogen, and atoms form to fuse helium atoms, so we have nuclear fusion happening there as well. So the planets don't emit light on their own, and they can be seen as a reflection of the light of the Sun on their surfaces. So just a little bit of interest about the distance. So there's an acronym there. My very energetic mother just served us noodles. So that is in order of the planets and in order of distance to the Sun. So if you're ever asked that interesting question, usually you don't need to know the actual kilometres there. If you have a look at them, they're pretty massive kilometres. But if you can remember, my very energetic mother just served us noodles, and see that they're in order from Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune there. So with the solar system, there is also some concept confusions as well, some misconceptions with our students, and it's important to highlight that Pluto is no longer a planet. That's a very recent discovery there, as it doesn't fit the new criteria of being substantial enough to have cleared its orbit of other larger objects. So Pluto therefore is considered a dwarf planet. A couple of facts about the Sun. The Sun contains more than 99% of matter in the solar system. And it is the mass of the Sun that provides that gravitational pull that keeps the planets in their orbits. And each planet describes a more or less elliptical orbit around the Sun. And with the exception of Pluto, these orbits are all roughly the same plane. And the Earth completes an orbit around the Sun every 365.25 days. So therefore that's why we get those differences in our calendar with leap years and that as well, that comes into that. So day and night at the same time as the Earth is travelling on its annual orbit around the Sun, it's also rotating on its own axis. So as the Earth is bathed in light from the Sun, it's possible to imagine that one hemisphere will be in sunlight while the other is in darkness. And that is because the axial rotation, a fixed point on the Earth, will experience a period of light there, and you can see that the axial tilt of the Earth in the diagram that's on the right hand side of the paper as well. So day and night, simulating day and night in the classroom is one activity that you may be able to help with and use. And if you've got a standalone globe, or some of the old globes that aren't around that much anymore, you might be able to use that and a lamp to simulate day and night and simulate the orbit around the Sun and how much we depend on the Sun. And you can then move into that information from the space science into our seasons here on Earth. And we know that from our experience that seasons change, and our students know this very well as well. So we can tap into this in the younger students, particularly our foundation students, where you can tap into this. So the effects of these changes can be seen and felt, particularly in terms of day light length and temperatures. And what causes this annual and predictable cycle of seasonal change? So it occurs because of the Earth's axis is tilted at an angle of 2.5 degrees from the vertical, so relative to the direction of sunlight and the heat from the Sun. So what would happen is the Earth's axis was not tilted. I'll leave that with you. That's a really good question to pose to your students. Would there be seasons? Day and night would be 12 hours long for any given place on Earth, and equatorial regions would still be warm and polar regions would still be cold. And some of those extremes, they might then revert back to the extremes there as well. So just having a look at that axis and that the axis or tilt, are going around the sun, and you can see as we move around how the southern hemisphere and the northern hemisphere are at different points, the closest facing to the sun. So we can also move on to the Earth and the Moon, and the planets of the solar system are satellites of the sun. So some of these planets have orbiting satellites of their own, and Jupiter has 12. And 4 of those are visible through ordinary binoculars or even a telescope as well. Some of the observatories have telescopes, and I know there's one in Melbourne, Melbourne Gardens there, that has a really strong telescope that you were able to look at Jupiter in particular there and its satellites. And if you get a chance to go to some of those nights where they have on where you can view the sky and the stars and the planets, I'd suggest that it's a good opportunity to go along and have a look at another part of science that we generally don't tend to look very much at other than looking at the planets. So the orbit and rotation of the Moon. The Moon is the Earth's satellite and our closest celestial neighbour. It has a diameter of 3.456 kilometres, and it orbits the Earth at a distance of 382,400 kilometres. So those figures there and those numbers there are actually really good for your grade 5-6 students, and it comes out on their MAI testing, their maths testing that you may do at the start of the year to see what growth point your students are on for maths. Using these large figures and like the distance from the sun, they will help your students to prepare for NAPLAN. As well as the MAI test that you would most likely in Victoria be conducting for maths and maths assessment. A complete orbit takes 28 days, so that's a lunar month. And during the orbit of the Earth, the Moon rotates once on its axis. It also has the same hemisphere of the Moon that we see from the Earth. And here we've got the different phases of the Moon. So once again, it's another activity you can do with your students, maybe in middle years would fit into this really nicely. So the Moon is bathed in its own light from the sun. During its 28-day orbit around the Earth, the appearance and the shape of the Moon changes, and these change in appearance, and so they're known as the phases of the Moon. There are also misconceptions there as well, that the phases of the Moon are not caused by the shadow of the Earth on the Moon's surface, that they are caused by our view of the Moon as it orbits the Earth there. So just be very careful with some of those concepts that we can cause confusion with our students. So part of moving into Earth and space sciences is also looking at galaxies, which is something that we don't tend to do a great deal of. The Sun is a medium-sized star in a collection of stars, and a star system is known as a galaxy. And our galaxy is known as a spiral nebula, and it has an estimated population of 100 billion stars, which only some of 6,000 are visible to us, to the unaided eye there. And the entire galaxy is rotating in space. So just be careful with some more misconceptions. That stars do not appear during the day. We can no longer see them due to the light from the sun. So light pollution in urban areas also can make that a little bit difficult. But the stars are always there, and we just can't see them because of the sun's rays. All right, so I know it's a really quick one today, but just in summary, what do we know? The Earth is turning on its axis, and the turning Earth is orbiting the Sun, and the Sun is moving around the galactic centre as the galaxy rotates in space. So the galaxy is moving apart from all other galaxies there. All right, I just wanted to wish you all the best for your future and for your teaching career, and good luck with your practical applications, and I hope that you, when you're on placement, I hope you get to have a chance to experiment with the science curriculum in particular, and continually grow your knowledge in science and grow your confidence in science, so that when you do have your own class in the future, that you will be able to jump straight in and go, yeah, I can do this. So you've been absolutely wonderful this semester, and I've been very privileged to be your LIC for this semester, and I do hope everything goes well. Keep in touch. I love to hear your successes, and I love to hear about where you end up, whether you end up in the career that you thought you would, or you take a side shot, as some of us always do. I'd still like for you to get in contact in the future and let me know how you go. So thank you very much for the semester, and good luck moving forward.